Hello, everyone, and welcome to the channel. It is always good to see something different. I just stumbled upon this new project which tackles the RAG problem in a different way. Or should I say, it makes ragging more flexible and more adaptable. This new project, where this creator demand is sharing an agent that can tackle complex RAG tasks, whether they involve challenging questions requiring reasoning or difficult data. RAG stands for Retrieval Augmented Generation, and at very simple high level, it means to give a large language model context around your own custom data. And the basic purpose of RAG is to make sure that whenever a question is asked from a large language model about some data which is not really in the training set of model, but you just want the LLM to provide your own data, and you want to make sure that LLM doesn't hallucinate if it is not aware of the data. So that is the whole point of it. So this agent includes a planner that dynamically creates and updates tasks necessary to solve the problem, along with retrieval and answering tools equipped with hallucination checks. The agent is not only easier to install, but also it increases gradually in complexity. Plus, this is designed to answer complex questions from a given dataset. The system uses a controllable autonomous agent that relies on a deterministic graph, which acts as its brain. The agent is capable of answering non trivial questions by retrieving information from vector store and using LLM functions. And this project includes several steps. So for example, your data is in PDF format, so this project enables you to load the files in PDF, and then it processes it. By processing, it means that it just divides it into smaller chunks, then it gets converted into numerical representations or vectors, and then from there you can summarize it. You can encode it in the vector store. LLM functions can be defined, and it also offers you a graph based workflow. And this person has also shared a notebook too, which I will drop the link in video's description, and you can also read through it. So in this video, I'm going to show you how you can locally install it and then play around with it. One thing, I haven't found any way of using it with the local models through OLlama or any Llama CPP. So you would need to have OpenAI's API key, which is a paid option, or and of course you would need to grab the Grok API key, which is a paid option, but you do get some generous API credits for that. So you would need to go to platform.openai.com to grab your OpenAI's API key, and then you would need to go to grok.com or groq.com to grab your Grok's API key. So once you have those keys, you will be setting it in the project. So let's get started and see how to get it installed and get it working. Before I do that, let me give a huge thanks to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs. This is my terminal where I'm running Ubuntu 22.04, and this is my GPU card NVIDIA RTX A6000 courtesy Mast Compute. But as I will be using an API based model, so you don't need that much VRAM for this. Let me clear the screen. Let's create a Conda environment to keep everything separate and simple, and let's wait for it to get installed. Conda is created. Let me install some of the usual prerequisites, torch and transformers. Let's wait for it to finish. Prerequisites are done, and now let's clear the screen and git clone the repo of this controllable agent. That is done. Let me cd into it. Okay, that's it. Let's clear the screen, and I will also drop the link to it in video's description, so don't worry about it. Now let's install all the requirements from this repo with the pip command, and it is going to install fair bit of stuff. So let's wait for it. and all the prerequisites are done. Now let me clear the screen. Let's do the ls-ltr just to see what is available, or maybe I'll do ls-ltr-a to see the hidden files too. So there is no .env file. Let's create a .env file, and then you can open it in your editor. Let me open it in the Vim editor. From here, you just need to specify your API key. So as I mentioned earlier, you would need these two API keys. One you will get from platform.openai.com, the top one, and the other one from grok.com. So let me set my keys, and then I will be just replacing this here with my keys for both OpenAI and Grok one, and then I will save the file. So let me do it and then exit from here. I have set my keys. Let me clear my screen. Next up, let's install our Jupyter notebook, and I will be doing everything in that Jupyter notebook. And by the way, if you don't have this system, you can run these commands on free Google Colab. You don't even need a GPU for this. So let's wait for it to install this Jupyter notebook, and then we will open it in the browser. And this is my Jupyter notebook. First up, let's import some of the libraries. Now all the commands which I'm going to use here, as I said, I will drop the link to the notebook. So no need to type it or anything, just you can follow along. So all we are doing here is we are importing a lot of stuff from LangChain, from the other libraries which it has installed. And what we are going to do in this notebook, we are going to see how this controllable RAG agent works. So for the sample, we will be just picking up a PDF file which contains a Harry Potter book, and then from there we can ask questions. And the purpose is just to show you how this thing works. So let me import all of this stuff. Libraries are imported. Next up, let's grab our API keys from the environment. And because I don't have the Harry Potter's PDF book, so what I have done is I have just taken my own PDF file. I have thrown in some dummy data about myself in that PDF, and I will be using that. So let me do that. So I have just set the path to my local system. Next up, let's do the next step of the RAG to split this PDF into some sort of chunking. So this is all we are doing here. This is a very standard thing with the RAG. And then you can see that we have divided it into chapters. From there, all you need to do is you can just load any PDF file with the help of PyLoader, where you are just creating the codes from the book with the help of this agent. And then all there is left is to create a prompt template for summarization, which you can of course change, but I think this one is quite simplistic and good, where you can just define this in this format. And now in order to get the summary of your own data, you can just copy paste the function from their notebook, which is this, where all it is doing is it is just using this preamble as what exactly this function does, and then it is using GPT 3.5, which is a cheaper model from OpenAI, and from there it is going through chapter by chapter, calculating the number of tokens, and then giving you the summary of your document. So let me run it. That is done. And now if you want to generate the summary of each chapter one by one, all you need to do is to just run it through the loop. And then you can simply use the following function from their notebook to convert the text into numerical representation or a vector, or in other words, we are encoding the data. That is done. It is all using OpenAI's embedding model. And then you can create the vector store locally, and they are using this FIAS, it seems. I'm not sure if you can use any other, but I think this is a fine option. It's a lightweight one. And once that's done, the last step is to initialize your retriever, and this is going to retrieve the top k results from your vector store, and this you can embed in your pipeline. So that's it, guys. I hope that you enjoyed it. So basic purpose of this agent is to give you an end-to-end um, encoding and retrieval mechanism from your own data. It creates its own vector store and then takes care of chunking of it, pre-processing it, and then encoding it and storing it, and then the retrieval. And you can just pick this code up, put it in your own RAG pipeline, and then use it accordingly. Now, one drawback of this technique is the cost. Because I have just used a dummy data which was not that costly, but still, it has costed me around $5 just to run this on one page of PDF, which is a big no-no in my case. I think there are a lot of other options available which you can use for free. So, but one thing or one scenario where it makes sense is the complex RAG scenarios where you have a lot of documents. But I think in that case, instead of going through API based one, I believe more better option would be to use local embedding models and local LLMs for inference. I will drop the link to it in video description. Play around with it. Let me know what do you think. Still a very early project, so be ready for a lot of things breaking down the road. And but I think a good start for a sophisticated RAG pipeline. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.